Okay, so we're going to talk about vectors in 2 space and 3 space, we can call it. We can call it 2D, 3D, 2 space, 3 space, r squared, r cubed. This is how we talk about dimensions in vectors. So we know already that in terms of location on like a plane that is like the board and that you've been using for your whole math life, is just xy. It's always been 2-dimensional, just like this. And if we have a vector OP going to a specific point P that is AB, we know the x coordinate, we know the y coordinate, so we know the distance in the x, distance of the y, soft. Okay, so we use that xy coordinate to understand location in 2-dimensional space, and now we're going into 3-dimensional space. So it could be a little tricky to understand it if you can't draw it. We like to visualize vectors in space. You could do it without drawing it, as long as you understand like parallel dimensions, I guess you can, no pun intended with parallel dimensions, but as long as you understand parallel planes, it'll make a lot of sense. So for instance, if I have a vector OP that is in 3 space, I actually have to account for y, x, and z. So the first thing that's going to change is look at our axes. This is not x anymore. Okay, we rotate it, and now this is y, this is x, and this is z. Okay, this is just a system we use. It's not the only system that you can use, right? But clearly, if you're using 3 space, there's going to be different types of rotations that you can use to illustrate that 3-dimensional space. So let's just take a look at this vector OP. So if it has 3 dimensions, it has to have a horizontal, a vertical, and you can see this as a diagonal, but really it's coming out, right? If you can visualize that. Okay, so it's really like this. Okay, but we draw it like that because it does a good job. You know, if we draw a prism, we can really see the three-dimensional vector. So I can start with just the x. I have to go a over. So I'm looking at my coordinate in x, and I go on the x-axis, and I have to go a. I have not moved in terms of the other coordinates. So this is a, 0, 0. Now from a, if I move horizontally, I have to move horizontally the y value, which is b. So now I'm at a, b, 0. Okay. The last thing I have to do is now move vertically. So I'm going to move from here up, and that's the z coordinate. So I'm going to add c to that, and I'm going to find myself at a, b, c. And from the origin to p is going to be my vector. Now the order of what I just did doesn't matter. You can do it in any order. I can go up first. If I go up first, what's this coordinate?
0, 0, C.
0, 0, Z, Canadians. And then I'm going to go to E. What's E?
0, Z. 0, B, Z.
0, B, Z. Yep. What about F?
A, B, no. A, B, Z. A, 0, 0.
This one's down here.
Oh.
It hasn't moved the next. It has not moved vertically.
A, 0, 0.
Nope.
0, B, 0.
0, B, 0. It only has moved in the Y dimension, right? That way. What about this one? How do we find this one?
A, 0, Z.
A has not moved that way. 0 and Z. Yep. Okay, so understanding coordinates and how to find them, you can see how difficult that could be, especially when you're not drawing like a really nice diagram. So I'm going to help you understand how to draw something really accurately so you don't make mistakes with understanding or not understanding visualizations. So I want to draw a vector OP where P is 6, 2, 4. Okay, so use a ruler. We are actually going to measure. Okay, we want to measure and we want to try to know, we have to draw parallel lines. Parallel lines are easy. I did it on the board like this, you know, I grabbed that line, I just went like this. Ish. Parallel-ish is good enough. So, first thing I'm going to do is I'm going to plot those intercepts. X, Y, and Z. So 0 and 6. I'm going to do it a little bit to scale, but I don't really have to. I'll pretend this is a 6. So this point is 6, 0, 0. I'm going to go to the y value, 2. Z value is 4. this is 0, 0, 4, and this is 0, 2, 0. Okay, so that's my starting point. If you think of it, all you have to do is move in the other 2 dimensions from every point. That's it. And the distance you have to move is the distance of, like, in the x, this is, I'm going to measure it with my ruler, and I scaled it. This is 30 centimeters, for instance. And I'm only saying 30 centimeters because I actually want to graph it properly. So I have to graph a parallel line that is 30 centimeters long from the other 2 points. So I'm just going to move this here. I'm going to try to make sure it's parallel, and wherever it's parallel at 30, I'm going to draw a dot. And I'm going to do the same thing from here. 30 centimeters from here, parallel to the other axis, or the x-axis. This-ish. Parallel-ish. Okay, I change it because I know that these have to be horizontal, right? Because that's just the y-coordinate. It has to be perfectly horizontal. It's still a little tilted to my eye. Okay, and now I already have this plane. Okay, I've already created one plane. Let's do some stuff at other areas. You know, I started with the diagonal one. Usually I leave the diagonal one for the end because it's the hardest one. Doing the horizontal and vertical lines, that's pretty easy, especially if you have a grid paper. Just count the boxes. It's really easy. So this, I scaled it 10 centimeters, but it's 2 boxes in your sheet. So I'm just going to go here, you know, and you can just go vertically. This is vertically. Okay, and this point also needs that angled x value. So I'm just going to every point and making sure it has every single dimension accounted to it. So I'm going to try to be parallel to x. I'm going to go here, and 30 in length. I'm going to go here. Okay, and now I actually have something's wrong here.
Sir, it's not parallel or straight.
What, this one?
Yeah. It's like not parallel at all.
Yeah, it's horrendous. And this is too close together. Yeah, this should be further.
Little sheaf.
So you took music, didn't you?
A little skeef for sure.
Yep.
See, I can just kind of guess based on the location of the other ones, right? Now I can go like this.
Can you explain that?
I could go like this. And I have my 3-dimensional prism. Okay. But where is the point that I'm trying to find? Where's the vector? Follow every dimension and you'll get to the vector. I need a 6, a 2, a 4. 6, 2, 4. This is P. So from the origin to that point is vector P. And if you want to label all the other side lengths, I mean, look at what I talked about. I'm like, I went 6 this way, 2 this way. Therefore, this is 6, 2, 0. Right?
Yeah.
Let's start over here. I'm at 2. I'm going to go 4 up. Well, that means this point must be 0, 2, 4. That's it. Okay, I'm at 0, 2, 4. I have to include the x value now, which is 6. Yeah, we already know that this is 6, 2, 4, the p value. Okay, well, now I don't have to start from the beginning. I can just start here and eliminate the y value. See that? I'm going -2. So this is going to be 6, 0, 4, this point right here. Okay, so just understanding moving around in space is really easy once you have your 3-dimensional shape. Only once you have your 3-dimensional shape. Okay, a few things about planes. Think of the xy plane. This plane down here. Okay, that's a plane. No matter where a point is on that plane, we know that the z coordinate is 0 on the xy plane. Okay, so we actually call this the equation of the xy plane. So the equation z equals 0. The equation of the xz plane is y equals 0. And the equation of the yz plane, obviously, is x equals 0. Okay? It comes in handy if you know a 0. If one of the coordinates is 0, basically you know what plane it lies on. And it's really important to understand three-dimensional vectors because, I mean, planes are max 3D. We have to understand like actual two-dimensional things in three-dimensional space. So without understanding and learning how to draw this stuff, it's going to be hard to visualize what we're talking about with planes. You could still do the math, but I don't know about you, I like to visualize what I'm doing because in case I'm stuck in a corner, I can find myself out with my brain instead of with structure. Okay, so that's pretty much it in terms of drawing vectors. A huge part today is just going to be learning how to draw this box and learning how to navigate through 3-space on a 2-dimensional sheet of paper. That's a skill on its own that you have to practice, and it's going to take some time. You don't want to say something else? Nah, not right now.